Hello, welcome to Topper Machine. I'm Josh Topper, and today we have a conveyor roller, an idler for a rubber belted conveyor for an asphalt plant. And this thing has been running for a lot of years and there's a lot of wear on it. And I'll show the wear as soon as we get it up in the lathe. The customer brought it to me just like this. Filthy, nasty, I had to pressure wash it. But they left that bearing on and they wanted to leave that bearing on. They wanted to only take one off. So we're gonna see if we can do it with the bearing on. But I'll get it in the truck, get it in the lathe, set up, and then I'll show you how bad this really is. All right, so I got her chucked up here, and we're gonna hope that bearing works for us. Worst case, I'm gonna take it off, but I mean, you should always take your bearings off when you bring it to a shop anyway, but this is just a kind of a crappy straight edge, but it's sitting good on each end. So this one is not bad. I've seen worse. So what we're gonna do is I'm gonna start machining in the middle, and I'm gonna take these, true these. It looks like we have an even number. 1, 2, 4, 6, 2, 6, 8, 10. 10 discs. So I'm gonna start in the middle here on these 2 discs, and we're gonna turn these down just a little bit to true them up. And then we're gonna go out from there, progressively turning a little bit more. So we'll start here, true it up, and then maybe 50 or 100 thousandths more than this one, smaller, and another 100, and another 100, another 100, something like that. We want a crown on it so it'll track better. This one used to have a crown, and over time it's wore this way. So by having the crown, the belt will track a lot truer. And the problem they're having with these is the belt is not tracking well because it's doing this. It doesn't have that crown to hold it straight. So let's go ahead, fire up the lathe, and see what we can do. Now before we get started with that, last week I noticed my coolant was getting pretty nasty. The lathe was getting a little bit kind of oily from the whey oil, and I oil the wheys excessively probably, but I don't want to wear my machine out. So here's my coolant tank, and the coolant, over the weekend it settled out and the oil floated to the top, so I've got my oil skimmer going. This is just a little belt oil skimmer, runs the belt, scrapes the oil off, and depositing it down in the pan here. So over the weekend the oil floated to the top. We're going to run this probably all day, and even into tomorrow. We'll see how it goes, and that should clean my coolant back up. And most CNC machines are doing this. I've done this for a few years now. The coolant that was in the radial drill, I pulled out about 4 gallons of oil out of that thing. So I bet you I'm gonna get probably 2 quarts out of this. All right, well, it looks like that bearing is just gonna spin, and that's not gonna be a problem. Overall, she looks pretty good. So I'll bring her in. We'll make sure my compound doesn't need to change angle. It might, just for clearance there, but we'll go ahead and bring it in, take a look at everything, and then adjust from there. All right, the clearance is pretty close. I am gonna change my setup a little bit because I just don't like that. That's a lot better. All right, we'll go ahead and start it up and just touch it off on the center rollers and just see how much we need to take off. We'll just take minimal amount on this. I'm just going to take 25 and we'll see how it does. Come over to the other one. All right, they cleaned up equally. That's our starting point, and from there we step it down. So obviously the outer ones are going to be bigger. I was noticing a little bit of vibration. I could feel it and hear it. I don't know if you could, but I'm going to slow my RPM down just a little bit. This is a much heavier roller than I did last time, bigger shaft, but these plates are AR. They're either AR 400 or AR 350 or something like that. So they're a little bit tough, but we'll get this. It won't be a big deal. All right, so I took her down to 125 RPM, and I'm just gonna leave it at my 0, and we'll see if it'll cut. Beautiful. We'll go to the next one. We'll just cut them all to size first, get them all trued up. I'll do this end first, and then we'll move to the other end. I got 200 thousandths to take off on this one. And we'll do it 50 at a time. I got 700 thousandths to take off of this one. So I'll take that 150 at a time also. bring it in, see how much I got to take off this one now. About 800 thousandths. I'm going to do this one a little differently. I'm going to come in and just kind of face into it and see how that goes. All right, I took a little bit bigger bite than I should have there, and I've got a little bit of a rat's nest. I'm gonna try to get it out of here because this will be dangerous. We'll just back off the cut, but this is working great coming in that angle. Yeah, I think I'm gonna get a side cutter. All right, I actually just went and got the tin snips. I think this will work better than the side cutter even. And it sure seems to be cutting nice. All right, this end is all turned to the same depth. I just got to do this end. We'll get this done. I'm curious if there's gonna be vibration out here, because the last ones I did were a smaller shaft, but we were getting chatter on this end. So I had to do this half and then flip it around and do that half up by the chuck to cut that vibration. But this one's doing really good. I'm very happy so far. So we'll go ahead and run these into the 0 point that I already established here, and then we'll come in and we'll start tapering them all. All right, I'm getting some chatter. I'm gonna go ahead and slow it down a little more and see if that'll do it. Like I said, this is always kind of the issue with this kind of stuff, these long ones with the vibration, and we'll see if this will take care of it. Nope, and that made it worse. So we may have to just cut it off a little at a time off the face. You know, 50 thou at a time. We'll see if that'll work. And I'm gonna run at 180 instead. So we were at 90 and it was worse. We're gonna try it at 180 and just see if it's better. Oh, I think this will be fine. Maybe not. So I just increased my depth of cut from 50 to 75, and that actually made a difference. And this is 100. We'll see if this makes a difference. Yeah, that's actually better. So as you can see at the chuck end, it's all nice. And the closer we get to the tailstock, this one's really bad. And I think what's causing this is, see, they're welded on this side, but not on this side. The end one is welded both sides. This one just welded on the outside, not on the inside. Same here. And they're all welded on one side except for the end ones, but the closer you get to the chuck, the more stability you have. So I think that's what's going on. I really should probably pop that bearing off. That looks like it's gonna be a nightmare if I flip it around and do it, but we'll try a couple things first and see if I can't do this to get it down to size, and we're gonna do this end first. So I'm gonna do 50 thou steps. So start 0, minus 50, minus 100, minus 150, minus 200. Before we do that though, let's throw the straight edge up there and see what we got. Looks like we're straight all the way across. So now we'll start doing the steps. I'm gonna slow it down one bit, one speed down to 125, and slow my feed rate down as well and see if that'll take care of it. Maybe we gotta do 25 thou in a pass just to keep the chatter out on that end, but we'll try it. All right, so I got a little chatter there, but this don't look bad. I'm increasing my feed rate though, and we're still taking another 25. We'll just see how it does. Worst case, I can polish this one, and then we'll have to fix it on the rest of them. And I'm still getting that chatter. All right, so this just tells me that I'm gonna have to pull that bearing. So we'll go ahead and get this end done first, and then we'll flip around and we'll get that bearing off and do the other end. All right, that was 50. Take the first 50 on this one. And then the 100. All right, let's see if I can take 100 because we're up by the chuck. And then my next 50. This is 75. We'll take 75 twice, and then 50 for the last pass. They'll give us our 200,000 step. All right, let's take a look at what we did here. So these are the center two. She's sitting flat. And so we just put a nice little crown on it so that that belt will track better. Now I'll have to get that bearing off and flip this sucker around and do the other end because we're just getting too much chatter this way. So I just called the customer to let them know the bad news. We got to pull the bearings, and I guess they're going to have to do that from now on, but he said they had to cut them off on the other end. So we're going to try pulling it first, see how it goes. Hopefully it goes well, and if not, then I'll torch them off because we won't have much of an option. So he said go ahead, torch them off if you need to. Otherwise, yeah, if they'll pull off, we'll save them. So. Looks like it was Loctited. Just gotta take them all the way out, make sure there's nothing else in there. All right, I know this contraption looks a little ghetto. It's some of my clamp bars and some threaded rod, and we're just gonna try pulling it, just tightening up the bolts, and I think it'll go. That's moving. Moving good. There it is. That came off real good. They'll be able to maybe reuse this if they want to. Awesome. All right, let's get this thing out of here. Clean the crap off that end, the grease and stuff, and spin her around, and then we'll be able to finish this guy up. All right, let's do this. We'll come into the center, we'll touch off, make sure we're still good, and then we'll go ahead and get these far ones done. Still good. I'm just going to try to take a light little pass on this guy just to clean her up a little, get that chatter out of it. To be able to do about 5 thou. All right. Much better. And we mostly got that chatter out of there. I could go a little more, but I think that'll be just fine. It'll wear on the belt. Over time, it'll smooth right out. Very nice. You know, and obviously just not enough support with just the tailstock there. We got to have flip it around to make this work best. And I think if they were welded both sides, we wouldn't have this problem, but it all in all went well. So now we'll throw the chamfering tool in there, we'll just come in and hit each side, knock the burr off, and this guy's done. Absolutely beautiful. Nice taper to it. Shouldn't be enough to keep the belt tracking just right. Again, the reason we do the crown to these is for belt tracking. Now, if you look at old farm machinery running flat belts or your flat belt machinery that people have, you look at the pulley, they've got a little crown to them. They're not flat. And that's to keep the belt tracking properly. By putting the crown on here, these conveyor belts track so much better. The way it was all concave like that, the belt was going all over the place. Even flat, they'll have a little bit of issue, but having this convex shape, this cone, that allows it to track better and will give it a little more wear life. So that's why we started doing this. Did this last year for the customer on the first one, and they loved it. It worked so good. They were actually looking at buying new ones until I surfaced these, and the first two I did for them, and that cured all of their problems. So now we're going to surface all of them until they get down to the point where they're just too small to do anymore. But they should get about 3 to 5 years out of this before it needs to be done again. So this is saving them a boatload of money. So I'm going to go ahead and get this one out of here and get it to the customer. And I hope you enjoyed the video. And with that, till next time, get out in your shop and get it done right the first time.